Have you ever stopped to ponder the origins of the universe? It's a thought that has puzzled humankind for millennia, and yet we've managed to gather some fascinating insights. Let's take a step back, way back to the very beginning of all matter, space and time. We're talking about the Big Bang. This wasn't an explosion in the traditional sense, but rather a rapid expansion from a single point of infinite density and heat. Imagine everything that exists all squished into a single, infinitely small point. This, my friends, is what scientists call a singularity. Now picture this singularity. It's incredibly hot, unimaginably dense, and yet it's about to do something extraordinary. In less than a fraction of a second, it begins to expand. And we're not talking a slow, gradual growth. No, this is an expansion so rapid, so explosive, it's beyond anything we can truly comprehend. As it expands, it begins to cool down. Particles start to form. First we have quarks, then protons and neutrons, which eventually come together to form atoms. The universe, as we know it, is starting to take shape. But when did this all happen? Well, scientists estimate that the Big Bang occurred around 13.8 billion years ago. That's right, billion with a B. It's a number so vast, so immense, it's nearly impossible to wrap our heads around it. Our entire history, everything we know, everything we are, sprung from that single moment. This is the birth of everything. From the smallest speck of dust to the largest galaxy, from the tiniest microorganism to the most complex life forms. Every star, every planet, every grain of sand, and every living creature all owe their existence to that initial burst of expansion. And so, in the blink of cosmic time, everything we know and don't know sprang into existence. From a single singularity, the universe as we know it was born. And the story of our world, well, that's just beginning. Imagine, if you will, a universe still in its infancy. Picture a vast, seemingly infinite expanse filled with a sea of gas and dust. This was the raw material of the universe, the building blocks for everything that was yet to come. Hundreds of millions of years after the Big Bang, the universe was a stage set for a grand spectacle. Amid this cosmic soup, gravity began to flex its muscles. It started pulling together these clouds of gas and dust, coalescing them into dense pockets. These pockets collapsed under their own weight, triggering nuclear fusion at their cores. The result? The birth of the first stars. But the universe didn't stop there. These stars began to clump together, forming the first galaxies. These weren't like the spiraling, picturesque galaxies we know today. No, these were young, irregular, and often violent places. Yet they were the cradle of the cosmos, the nurseries where future generations of stars would be born. Now let's introduce a mysterious character to our story: dark matter. This invisible substance doesn't interact with light, making it incredibly hard to detect, yet it plays a crucial role in galaxy formation. It provides the scaffolding around which galaxies form, its gravitational pull helping to shape and hold these cosmic structures together. Through this chaotic dance of cosmic forces, galaxies began to take shape, setting the stage for the next chapter of our story. So, where does our little corner of the universe fit into this grand cosmic tale? Let's rewind about 4.6 billion years ago. That's when our solar system, a neighborhood of planets and other celestial bodies, began to take shape. Imagine, if you will, a vast nebulous cloud of gas and dust. This wasn't just any cloud. It was a cosmic nursery, a place where stars and their accompanying planets are born. This process, known as stellar evolution, is common throughout the universe. Over time, the pull of gravity caused this cloud to collapse inward, forming a dense, hot core. This core would eventually ignite to become our sun. The remaining dust and gas spun around this newborn star, gradually forming a flat, spinning disk. Within this disk, tiny particles began to collide and stick together. Over millions of years, these particles grew, forming planetesimals, the building blocks of planets. The intense heat of the young sun blew away lighter elements, leaving behind only heavy, rocky material to form terrestrial planets like our Earth. Meanwhile, farther from the sun, cooler temperatures allowed for the formation of gas giants like Jupiter and Saturn. These planets captured hydrogen and helium, the lightest and most abundant elements in the universe, in their massive gravitational fields. From the ashes of cosmic destruction, our solar system was born, a testament to the ever-changing nature of the universe. Our world, so full of life, was once nothing more than a barren rock. How did we get from there to here? The question of how life emerged on Earth is one of the most fascinating mysteries of our time. Theories abound. each painting a picture of our planet's early days and the incredible processes that led to the birth of life. Let's start with the primordial soup theory. Picture a young Earth over 4 billion years ago. It's a seething cauldron of volcanic activity, with an atmosphere rich in methane, ammonia, water, and hydrogen. Lightning strikes and solar radiation catalyze chemical reactions among these elements, creating a soup of organic compounds in our oceans. This soup, according to the theory, was where life began, with simple molecules gradually evolving into more complex forms over millions of years. Now, let's consider another intriguing idea. Panspermia. This theory suggests that life might not have originated on Earth at all. Instead, it might have arrived from outer space, hitching a ride on comets or meteorites. These celestial bodies, carrying microscopic life forms or the building blocks of life, could have crashed into Earth, sowing the seeds of life in our planet's fertile ground. Regardless of which theory we lean towards, one thing is clear: water played a pivotal role. It's a universal solvent, a medium where chemical reactions occur, a cradle for life. The unique conditions on Earth, with its abundant water and suitable climate, created the perfect environment for life to take root and flourish. Over time, these simple life forms evolved, diversifying into the myriad species that populate our planet today, from the smallest microorganism to the largest mammal. Each creature, each plant, each organism, a testament to the resilience and adaptability of life. In the vast expanse of the cosmos, it's truly remarkable that our tiny blue dot could harbor such a diverse tapestry of life.